everyone. Today I am here to discuss with you another important periodic property, and that periodic property is known as electron affinity. And the other name of electron affinity is electron gain enthalpy. It is also represented by writing EA, that is E for electron, A for affinity. Now, as in the previous video I have told you about ionization energy. What was that? That was the amount of energy required to remove one electron from an isolated gaseous atom. Now, similar to that, if we want to change an isolated gaseous atom to an anion, that is negatively charged ion, by gaining electron, the atom will gain electron and it will change into anion, and then after changing into anion, certain amount of energy will be given out in the form of heat energy by that atom. Now, this amount of heat energy is known as electron affinity, and this electron affinity, whenever we write it, always it is given out in the form of product. So it is the energy which is given to the system. So this energy, as we are not providing it to the atom is giving out by gaining electron. That is why the energy is represented in negative values. Always we mention negative sign while writing the amount of the energy. Now, next is how we can define it. So it is the amount of energy released when one electron is added to the gaseous isolated atom, and then that gaseous isolated atom, it will change into anion. What is anion? The ion carrying negative charge is known as anion. For example, if we have chlorine, we know that atomic number of chlorine is 287, that is 17. Electronic configuration is 287. Now, when we add one electron to chlorine, then what will happen? Chlorine will change into chloride ion, that is anion. Why I am writing here negative sign? Because there is increase in number of electron. So 288. So the number of electron increased by 1. That is why I am mentioning charge 1. So it will change into an anion, and by gaining this electron, what chlorine will do? Chlorine will release certain amount of energy in the form of electron affinity. Let it be the value is, in case of chlorine, the value is it is equal to 349 kilojoule. Now this value, if I am writing it in the equation form, I will write plus because the energy is released. So that is why it is an exothermic reaction. But if I want to mention only the value, then what I will mention? I will mention the value as minus 349 kilojoule. So as I have told you, always we have to mention the negative sign in front of the number or the value for that energy. Now next is what are the various units for writing this energy or the periodic property? As similar to that of ionization energy, it is also a form of energy. So the units are similar to that of ionization energy. So we can measure it by writing electron volt per atom, or the SI unit for the same is kilojoule per mole. These are the SI units. So next is what are the various factors on which ionization this electron affinity depends. So there are two factors on which it depends. Number one, first factor is atomic size, or we can say size of the atom, and second is nuclear charge. So one by one we will discuss. First of all, we have atomic size. So atomic size, we know that atomic size of an atom, it is directly proportional to number of shells. And if the size of the atom will increase, then what will happen? The number of shells will also increase. And if the number of shells will increase, the attraction forces will decrease. Now, what is the meaning of attraction forces? There is a force of attraction between the nucleus, and which is positive, and the electron which is present in the outermost shell. So if we consider electrons present in the outermost shell, so there is a force between these two, electrons and the nucleus. So if the size of the atom will increase, the attractive forces will decrease. And if attractive forces will decrease, then the electron which is coming from outside, or the extra electron which we want to add, this electron will experience lesser amount of forces of the nucleus. Thus we can say that as the atomic size increases, atomic size is inversely proportional to electron affinity. If the size of the atom will be more, the size of the atom will be larger, the electron affinity values will be less. and if size of the atom will be smaller, the electron affinity values will be more. So they are inversely proportional to each other. Now the second factor is nuclear charge. So nuclear charge, what is nuclear charge? It is a charge on the nucleus, and basically it is due to the number of protons present in the nucleus. So the nuclear charge, it is directly proportional to attractive forces. So if the nuclear charge will be more, the force of attraction will also be more. Why? Because the central proton, if the charge on the proton will be more in the nucleus, then outermost electron, which is coming, which the atom want to attract, or which we want to give to that atom. Now this electron will experience more amount of force, and it will be attracted toward the nucleus with a greater force. So thus we can say that more is the nuclear charge, more will be the electrostatic forces, and if more will be the forces, then what will happen? The electron affinity's value will be more. So thus we can say that nuclear charge on an atom is directly proportional to electron affinity values. Okay. Now next is, what is the trend of electron affinity in a group or in a period? So one by one we will discuss. First of all, in a group, what will happen to electron affinity values when we move from top to bottom in a group? So what we have to do, first of all, we should remember one example. So I am giving you the simple example of first group elements. So I am writing here lithium, sodium, potassium. Lithium is having atomic number 3, sodium is having 11, and potassium is having 19. So we know that size of the lithium is small, and then size of the sodium is bigger than that of lithium, and size of potassium is bigger than that of sodium. Because it is having 4 number of cell, it is having 3 number of cell, it is having 2 number of cell. So now extra electron which we want to add. Now in this case, center, nucleus and this electron has to cover these two shells to reach or to experience the nuclear forces or the attractive forces of nucleus. But in case of sodium, electron has to face 3 number of shells to experience these forces. And in case of potassium, electron has to face 1, 2, 3, 4 number of shells to experience the forces of nucleus. So in this case, screening effect of these shells, it will be more in case of potassium, less in case of sodium, and least in case of lithium. So electron will be gained by lithium more easily. And if lithium will gain this electron more easily, then it will release large amount of energy. So thus we can say that the element which is present at the top of a group, that atom will have more electron affinity values, and the atom which is present at the bottom of the group will have least electron affinity value. So thus what we have concluded from this, as we move from top to bottom in a group, what will happen to electron affinity value? The electron affinity value, it will decreases. Okay. Now next we will talk about electron affinity value in a group in case of non-metals. So basically I will give you now we will take the example of fluorine, chlorine, bromine. Now in case of fluorine is having 2 number of shells, chlorine is having 3 number of shells, and bromine is having 4 number of shells. Okay. Now in this case, electron is there, smaller is the size of fluorine, so more electron affinity value will be there. In case of chlorine, size will be more than that of fluorine, so values will be less. And in case of bromine, the values are least. But so general trend is, as we move from top to bottom in a group, the electron affinity values will decreases. Now there is an exception that we have to consider, and it is very, very important. Electron affinity's value, generally it is noted that especially in case of non-metals, the electron affinity value of chlorine is more than that of electron affinity value of fluorine. So it is an exception that you have to remember. So why this trend is seen in case of chlorine and fluorine? Because in case of chlorine, the size of the atom is large. Why the size of the atom is large? Because it is having 3 number of shells. In case of fluorine, the size of the atom is small. Why the size of atom is small? Because it is having 2 number of shells. So in case of fluorine, we know that the atomic number is 9. Outermost shell is having 7 electron. 1, 2, 3, 4, 5, 6, 7. In case of chlorine, atomic number is 17. So outermost shell, again it is having 7 electron. 3, 4, 5, 6, 7. But due to the smaller size of fluorine, the inter-electronic repulsion, when it will gain 1 electron, 1 extra electron, the number of electron, now the number of electron changes to 8. Then they are 7 in number. After gaining electron, they will become 8 in number. So by gaining extra electron, it will acquire stable electronic configuration because it will have 8 electron in the outermost shell. Because of that, these 8 electrons, they start repelling each other. And due to these repulsion forces, the attractive forces of the nucleus will decrease. And because of that, what we can say, the electron affinity value will also decreases. So this you have to remember. The general trend is as we move from top to bottom in a group, whether it is metal or non-metal, the general trend is electron affinity's value will decreases. But in case of chlorine and fluorine, or in case of oxygen and sulfur, 16 group element, they are the 17 group elements. So in case of 16 group element, again sulfur will have more electron affinity value because of the larger size, and oxygen will have less electron affinity value because of the smaller size. Similarly, chlorine will have more electron negativity value, more electron affinity value as compared to fluorine, and fluorine will have less electron affinity value due to, what is the reason? Due to the inter-electronic repulsion by gaining electron. So hope it is clear to you. Now next is, what is the trend of electron affinity in a period? The value of electron affinity in a period. So when we talk about a period, then what we can say in a period, again I have told you, you have to consider one example of one period. So we are taking the example of elements of second period. So we start with lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then we have neon. So first of all, we have to consider this trend up to group number 17. I will tell you why we will not consider group number 18 in this. So there is a reason. So now up to 17, what is the general trend? We know that as we move from left to right in a period, the size of the atom will decrease, and if size of the atom will decrease, nuclear charge will increase. And I have told you earlier, nuclear charge is directly proportional to electron affinity. If nuclear charge will be more, electron affinity value will be more. So thus we can say that as we move from left to right in a period, the electron affinity values will increase. So if we talk about a period, lithium will have least value of electron affinity and fluorine will have maximum value of electron affinity. Okay, because these are non-metals. On the extreme right of the periodic table, we have non-metals, and we know that non-metals, they have tendency to gain electron. So easily they can gain electron as compared to metal. That is why all the metals, they have less electron affinity value, and all the non-metals, they have more electron affinity value. So now why I have not considered in this trend, why I have not considered the elements of group number 18? Because what is the reason behind? Neon, which is having atomic number 10. So electronic configuration, it is having 8 electrons in the outermost shell. So outermost shell is satisfied. It has completed octet. So if we want to add one extra electron in it, it is not willing to take that electron because it does not want to become unstable. So thus we can say that there is no need of gaining electron by these elements of 18 group. So that is why electron affinity value for this group is equal to 0. So this is very, very important question. So two important questions are there. Number one, why the noble gases or the 18 group elements, they have 0 electron affinity. So what is the reason behind? Because the outermost shell is having stable electronic configuration. It is having complete octet. So that is why no extra electron is added. That is why the electron affinity value is 0. On the other hand, question comes in paper. Generally we know that when we move from top to bottom in a group, the electron affinity value decreases. But Why chlorine has more electron affinity value as compared to fluorine. So in case of fluorine, when we add extra electron, due to the interelectronic repulsion, the attractive forces decreases, or we can say the electron affinity value will increase. So this is how we can show the trend of electron affinity in a group or in a period. So now one more thing I want to tell you, as I've told you, the other name of electron affinity is electron gain enthalpy. So you should know what is the meaning of enthalpy. Enthalpy is what? It is the total heat amount, that is called enthalpy. And what is the meaning of gain? Gain is addition. And what is the meaning of electron? Electron, you know, it is a subatomic particle. So the amount of heat energy, from the definition we can define it. From the name we can define it. How we can define? It is the amount of energy released when one electron is added to an atom. And how you can remember this? We know that electron affinity, it is having A for affinity, A for addition. So whenever there is addition of one electron, the amount of energy which is given out, that amount of energy is known as electron affinity. So like this you can remember this. Now hope you understood the trend or what are the various factors and the definition of electron affinity. Still, if you have any doubt, you can comment. You can send your suggestions. You can send comments in comment section. Thank you so much. Have a nice day.